All right, let's go ahead and get started. Thank you, everybody, for taking the time out of your day to attend the fifth in a series of 6 virtual events under the IPM Consider It Done umbrella. My name is Tim Freestone. As always, I'll be moderating today's webinar. Today's webinar will be brought to you by Akamai. Very special guest, Neil Cohen, the VP of Global Product Marketing, will be discussing how to maximize the success of virtualized applications and desktop deployment. I know something that is on the top of everybody's mind as everybody looks to move to the cloud and all the data center implications that involves. I'm going to introduce Shannon Hazing from IPM. She'll say a couple words, and then we'll go ahead and get started. Shannon?
Great, thanks, Tim. And thank you all for joining the 5th of this series of 6 virtual events, all part of the Consider It Done initiative. The IPM Consider It Done initiative was designed to provide you with the opportunity to learn key considerations for your current IT projects, and also to introduce IPM as the proven go-to firm for project execution. From Windows 7 migration to VDI and IT efficiency and cloud computing, IPM has worked with the presenting organizations to develop best practices that enable end-to-end project success. We hope you've enjoyed the series so far and are looking forward to today's event. So with that, I'm going to go ahead and introduce Neil Cohen, VP of Global Product Marketing at Akamai, discussing how to maximize the success of virtualized applications and desktop deployment. Neil?
Shannon, thank you very much. Good afternoon, everyone. I appreciate everyone taking the time to join us today. Got an interesting presentation as it relates to really a different way of maximizing your ROI on your VDI virtual desktop infrastructure. So I'm Neil Cohen. I'm the Vice President of Product Marketing at Akamai. Before I talk specifically about the work that we're doing in virtualization at Akamai, just a little bit about our company. We've been in business for a little over a decade. A lot of people have heard of Akamai beforehand because on any given day, we deliver anywhere from about 15 to 25% of the world's internet traffic. That means things like video on the web and MP3 files and file downloads, and every time you shop or you use social networking, that kind of stuff is delivered over Akamai. But we've made a transition in our business over the last 5 to 6 years to apply internet acceleration technology on our platform to help with business applications that are transforming any vertical, allowing them to leverage the internet as well as public cloud computing services online. You can see we're now a billion-dollar company, highly profitable, with more than 3,000 customers on our platform. We've been doing a lot of work over the last 5 to 6 years at Akamai as it relates to our application and cloud performance solution lines. The transition in enterprise IT with the use of the internet has really changed things. A couple of years ago, it was more about how do companies leverage the internet for their websites and their web-enabled business applications. But with things like virtual desktops, mobility, cloud computing, more and more of the internet is becoming weaved into the fabric of enterprise IT. Today, more than 20% of the Global 500 use Akamai's Internet Acceleration Solutions to transform their enterprise. We have a valued partner with IPM here in Greater New York to deliver technology specifically around maximizing ROI for virtualization products. And we've got a lot of experience as it relates to delivering enterprise applications on our platform, whether they're browser-based applications, whether they're applications that are delivered securely through VPN. And specifically today, I'm going to talk about some of the technology that we're applying to applications and desktops that are delivered virtually, agnostic to the protocols, whether the virtualization technology is built on, say, Citrix, Microsoft, or VMware. So a little bit about making sure that everyone's baseline on the market for virtualization. Everyone's very familiar with server virtualization technology, but not as familiar as it relates to extending the benefits of virtualization out to the client. You can see some analyst stats here where the adoption is starting to pick up steam, where you can see a Gartner quote here expecting mainstream adoption of hosted virtual desktops within the next couple of years, forecasting out about 70 million users just 2 to 3 years from now. And again, you can see another one kind of realizing that tipping point as it relates to adoption of VDI becoming the dominant form of client virtualization, which is a client and a catalyst for driving other technologies out to the client. So a lot of stuff and a lot of optimism as it relates to continued adoption and momentum as it relates to VDI deployments. One more stat here that I thought would be beneficial for the audience here is you can really see it taking form year after year after year. So you can see here a variety of different studies throughout the years as it relates to what the firm's plans are to adopt the following alternative client PC technologies. And you can see hosted desktop virtualization, local application virtualization, thin client hardware, all the different types of things that people are trying to do for virtualization at the endpoint, benchmarking it over the last couple of years. And you can see for all different forms of this client PC technologies, a major increase as it relates to the people that are either planning, already implemented, or expanding their current implementation. HVD, hosted desktop virtualization, jumping very quickly from 12% to 21% in just 1 year. And you can see the percentage increases for the other technologies. There's a lot of promise with virtualization HVD technology, and at the same time, there are some challenges that need to be overcome to fulfill the vision of what VDI technology is intended to bring to the market. You can see the first one here is very similar to other types of application delivery, whether it's over your private network or over the internet, that the further away a user gets from that virtualized infrastructure impacts the performance and the availability of the virtual applications, right? That has to do with the latency challenges that are introduced with distance. So if the application doesn't perform well, you decrease your adoption rates and you lose productivity, because with virtual desktops, the intention is that the virtual environment needs to run seamlessly and as quick as it would if the applications actually lived physically on the machine. Another challenge with virtualization is the high amounts of bandwidth that are consumed by these virtual protocols that are chatty because they require a lot of communication over the internet. And some of the research and discussions with our customers is when they roll out things like virtual desktop computing, even 100 users in a single branch can easily consume more than a single T1, E1 of bandwidth on its own. So it requires network upgrades to deal with the new protocols and the bandwidth that's required on the network. Another challenge with implementing VDI is the high cost and uptime issues that are often associated with long-haul private network connections out to emerging territories. So the traditional way of rolling out VDI is to go purchase connectivity point-to-point all over the world wherever you want to deliver your virtual desktops to. And there's often a very large capital and operating premium as it relates to the amount of money it costs to set up those private connections that give you very low packet loss, very low latency across the long haul. And another challenge with VDI deployments is that people are using their VDI environments differently. It's becoming increasingly less common for somebody to only need to work at their desk in an office in something like a call center where people take their virtual desktops and they need to access their applications anywhere. That could be mobile workers, that could be home office workers. You've got people who are on the corporate network and then they get off the corporate network and then they come back. You've got a whole new array of devices that need to be supported, including not just your laptops, but mobile devices and tablets. And people expect their virtual desktops to be accessible on any type of device with them anywhere. So to this point, desktops, the hosted virtual desktops definition is getting a bit antiquated because it's not only the desktop that are accessing the virtual environment. Sure, your desktop needs to be on the go, but tablets and smartphones are increasingly being used. Not only that, but you introduce the challenges of bringing your own devices in from home and expecting to be able to access your work applications on your home devices. There are different connectivity challenges with mobile devices than there are with desktop devices that are plugged into your corporate network, usually because they're often used outside of the corporate network, and either they're unable to or they're not connecting into the WAN. You've got Wi-Fi access, you've got 3G access, which has got a different set of challenges because of the congestion and the oversubscription in the mobile networks. And as more and more of the desktop delivery moves off of your traditional network and out to access over the internet, there's new challenges with the internet that you have to overcome to be able to get that high quality, reliable experience for your virtual desktop users. And that's a hard one to solve because unlike your private network, you go and buy a point-to-point connection with a certain SLA. The internet is the internet, where you've got thousands of networks, difficult to get an SLA because of all the different networks it needs to traverse. It's a best effort network, which means that things like latency, packet loss, routing inefficiencies can kill your desktop performance and availability in a virtual environment. So Akamai's been building on its intelligent internet platform for more than a decade, and what we're doing is we're putting more and more intelligence and capabilities into our cloud, our platform, so that you don't have to do it yourself. What we've done is we've built out a network today that spans in more than 70 countries in about 1,500 different network locations. We've got more than 100,000 servers, so that our servers are within a network hop of pretty much more than 90% of the world's internet users. So wherever you're getting your last mile connectivity, we're very, very close by. Similarly, the data center that you're hosting the virtual environment, we've also got a server in that environment, usually in the same data center and the same provider that you're buying your first mile connectivity from. And there's a lot of things that we do on this platform that's distributed all over the world. One of the things we do is we optimize virtual desktops with our own protocols. The important thing to realize here is that since that you can access the internet anywhere, we need to be anywhere, right? And what we do is we do it in a transparent way that by our servers in the cloud, you can think of it as essentially leasing optimization hardware and software that'll run in the cloud to optimize your VDI environment. So our services are based on a DNS resolution rather than you having to deploy any new hardware in your data center without having to change your virtual software, without having to deploy anything on the client side. It's all completely transparent based on a DNS redirect. Another visual way of looking at this, you can see here, is the Akamai platform in the middle, and your desire to deliver applications to anyone, anytime. And you can see the VDI user on the right. And Akamai's got a specific server that it can map dynamically to that VDI user that's right in proximity. And then you can see the virtual application infrastructure on the left. And similarly, Akamai's got another server there on the other side. Now, one of the things that's challenging with VDI is, for the most part, the content can't be cached. So a lot of the legacy things that people would do, like cache content at the At the right side of that bottleneck doesn't work for VDI because it's interactive and it's real time. So what we've done is we've built a special set of optimizations that optimize the real-time virtual protocols over the internet to take advantage of latency by minimizing the round-trip time, by being able to reduce the ill effects of packet loss, and also by being able to increase the throughput rate of the virtual protocols across the internet so that users very, very far away from the virtual experience, from the virtual infrastructure, get the same experience as somebody who would get it close to the infrastructure. What I'm showing you here are some examples of the optimizations we do on our network to optimize for VDI and transform the internet into a reliable business platform. What you can see here is some graphs from one of our data visualizations, akamai.com/DV2. And what you can see is I'm plotting the latency and the packet loss if you were trying to deliver a virtual desktop from Boston to San Francisco. You can see here that even in the United States, in the blue, that it would take about 120 milliseconds of latency to get across the country. And you can see that the 95 percentile on packet loss was about 25%. And for those of you who have experience dealing with packet loss over the internet, usually about 1% is the level where you'll start to notice a problem as it relates to a degraded experience for that virtual desktop user. And what you can see is with the green line, with the Akamai real-time path optimization, we've eliminated the ill effects of packet loss by optimizing on our own individual paths. And you can see we've cut the latency considerably to about 74 milliseconds of latency. You still have that thing you have to deal with, which is called physics, because it takes a certain amount of time to get a packet back and forth across the country. But we approach that physical minimum. Here's a more extreme example. So the further away you get from your virtual infrastructure, the worse the latency and the packet loss are going to get with the internet. And what you can see now is that same request getting routed from Boston to Beijing and vice versa. And what you can see is the packet loss, a lot worse, more spikes, consistently, you know, anywhere on the range from a couple of percent up to 30%. And you can see that the latency spikes tremendously, where a single round-trip time is now approaching almost 400 milliseconds of latency. So what Akamai is doing here is, regardless of where your users are in the world, it's giving you a highly reliable and a low latency and a low packet loss connection, which is the first step to being able to optimize and give good levels of performance and availability for virtual desktop users anywhere in the world at any time. Here's another example of some of the disruption that happens on the internet. So the other problem is not only do the virtual desktops need to perform well, but they need to be highly available. And what you're seeing here is a packet loss graph over 2 weeks' time from last year, where you can see that in the red line, there was a problem with the internet infrastructure, in this case a cable cut, and you can see the latency immediately spike up to 80%. And even 1 to 2 weeks later, you were still having a degraded experience. And if your virtual desktop users were trying to connect over that link, they'd have degraded experience for weeks. And you can see the green line with the virtual optimization for Akamai, where essentially we've detected that event real time, and we use some of our intelligent routing to steer around the problem and provide business continuity and high levels of availability in the cloud. You know, what is also important, not only optimizing the connection in terms of latency and packet loss, but how much data can you send across the internet or across any WAN technology, because the more data you can send more quickly, the better the virtual experience is going to be. So Akamai also has its own special communication protocols on the internet to be able to send lots of data across the internet so that your virtual experience for highly interactive and rich applications, regardless of the richness, you're able to send enough data quick enough to the virtual desktop so that you're getting a real-time interactive experience that emulates what you'd normally get with traditional PC technology. What I'm showing you here is throughput rates for a Citrix Zen desktop environment in terms of the types of throughput we can deliver for a VDI implementation that was hosted in Florida. And you can see the purple line is the normal internet in terms of throughput rates, and the blue line is the throughput rates using the Akamai IPM solution called IP Application Accelerator. And what you can see here is that how bad the experience gets from a user perspective even when you move across the eastern U.S. So you can see the degradation in purple moving from Florida to Cambridge. So that person's getting about 10–20% lower throughput rates. And then you can see dramatic differences, Bangalore, Seoul, and Singapore. So to my point beforehand, the further you get away from your virtual infrastructure, the worse the experience is going to be as a result of the latency that is introduced with distance. And you can see in the blue line the throughput rates with the optimization solution, where even as far away as Singapore, Seoul, and Bangalore, you're getting the same throughput rates you'd get for somebody who actually was in close proximity in Florida to the data center, which means you've taken someone at the other side of the world and you've brought them back in to get a local experience and highly reliable. Akamai's IP Application Accelerator, it's a complete managed service. It's an industry-first managed service that's done completely in the cloud for optimizing the delivery of virtual desktops as well as individualized virtual applications. There's a lot of benefits you realize with the internet, one of which is cost efficiency, right? The more and more pervasiveness of the internet, the cost dynamics of internet connectivity, the better off you can be as it relates to driving costs out of your business, the scalability of the internet, as well as the global reach of the internet. People have access to the last mile internet almost everywhere, and it's a lot more practical to ask virtual desktop users to get access to the internet than always having to plug them into a private connection. And as I mentioned earlier, it's protocol agnostic. So we support VDI products from all of the vendors, whether it's Citrix, Microsoft, VMware, or others. So one of the things you got to think about as you roll out your VDI strategy is the access type and the user. And what we're seeing is more and more of a hybrid environment within traditional enterprise IT, where you've got VDI users that are plugged into your corporate network, and there are technologies that are applied to optimize your VDI traffic on net. You've got more and more types of users that are trying to access applications and VDI infrastructure over the internet, and that's the area that Akamai provides solutions for. And increasingly, we're seeing decentralization of internet access out to the branch so that even people on their private network or in a branch office can get their virtual desktop infrastructure delivered over the internet itself. So we talked a little bit about the challenges, and now I've talked about how Akamai and IPM together solve these challenges. The first one had to do with the user proximity degrades with distance, and it impacts performance and availability. And I showed you some stuff how people, even on the other side of the world, get a good performing and highly available experience. We talked about the bandwidth consumed by these virtual protocols, and customers now have the opportunity to displace that traffic off of their private connections and deliver it over the internet. Ditto for driving some of the cost associated with that private networking. And we've also addressed the challenges of needing to be able to access VDI on all different types of device types anywhere in the world at any time, not just when you're plugged into the corporate network. A couple of case studies. The first one is a company called Cineract. They use Citrix delivery for their SIN capture application for clinical trials over the web. They are deploying the Akamai IP Application Accelerator to help facilitate the way clinical trials and pharmaceuticals are brought to market in clinical trial centers all over the world. They saw a dramatic improvement in the responsiveness of a Citrix XenApp application. They were able to reduce the performance-related complaints to the call center by more than 90%. They didn't have to solve the challenge of building out infrastructure or data centers or specialized hardware in colo in different areas of the world, and they estimated that to be a cost saving of more than $1,000 per location, $100,000 per location. It allows them to grow globally and expand globally at low cost, so they don't care where the clinical trials will take place. They can go wherever as long as the branch or the location at the endpoint has last mile internet access. And it allows them to be a lot more agile as a business by responding quickly and aggressively to new clinical trial bids. The second example is a company called Firefly Communications, and they're using the Akamai IP Application Accelerator to deal with performance issues, delivering Microsoft RDP protocol to rapidly expanding user group in Europe and Asia. And they wanted to keep their infrastructure centralized. This is a really interesting application as it relates to delivering technical training classes, being able to virtualize the experience into remote laboratories, and they saw a dramatic improvement in performance with almost an 800% increase in throughput rates for the virtual Microsoft environment. They reduced retransmission packets by up to 88%. And it enabled centralized hosting while being able to bid on new partners, new clients, and extend their technical training classes worldwide without building out infrastructure, while also enabling higher staff productivity. Before I wrap it up, I talked a lot about latency and packet loss and throughput rates, but those are often difficult to visualize. So the last thing that I thought would be helpful is there is a demonstration online, which is at www.akamai.com/VDI_demo, which shows a real Citrix Zen desktop environment. One of those environments is Akamized, and the other environment is not. And you can see a multi-step transaction between browsing on the web, flipping through a PowerPoint presentation, and you can get a real understanding of the responsiveness of the virtual desktop you get across these two different environments. So in summary, Akamai has a first unique managed service that transparently eliminates the latency and the bottlenecks that allow enterprise IT to be able to deliver virtual desktops out over the internet to users anywhere in the world. It helps address a lot of the costly IT and network build-out associated with traditional VDI deployments. It deals with a lot of
reminder to the audience that if you have any questions, feel free to post them in the chat module online there, and do our best to address them in the time we have left. If you can't get to them, or if the question requires more input, again, you can schedule a time using that scheduling feature to your right to follow up with Akamai and IPM. We have a question from Todd. It says, what changes need to be made to my infrastructure to deploy Akamai?
Okay, Todd, the changes that need to be made to your infrastructure is minimal. As I alluded to beforehand, there's no new technology or bandwidth that needs to go inside of your data center. There's nothing that goes on the client. There's no changes to your virtual images and software. The change that needs to be made is what we call a hostname or CNAME change, where what it would do is it would reroute the DNS request to the Akamai edge servers rather than directly to your origin infrastructure. So we work with you to make a simple CNAME or DNS redirect change, and Akamai takes it from there.
Okay, great. Thanks, Neil. One question from Raj. How difficult is it to integrate Akamai into our VDI implementation? Okay,
Raj, so the question was, how difficult is it to integrate Akamai into the VDI implementation? Usually not very difficult at all, where, as I mentioned beforehand, since it isn't a service, and all of the intelligence and optimization is in our cloud and not in your infrastructure, It requires a simple CNAME change to change the DNS pointers to Akamai. The thing that would be a good discussion to have is a follow-up to better understand the internet access points within your organization. Where do people have access to the internet? Are you backhauling traffic over your private network? But really, that would be the single other discussion as it relates to integrating Akamai into your infrastructure, is understanding the internet connectivity for the access method that you're dealing with specific to your corporation.
Okay, thanks, Neil. It looks like we just had a little bit of technical difficulty here at the end. There are a couple questions left. So we're going to go ahead and request that both IPM and Akamai address those via email. We'll get those over to you. And then anybody that can hear me now, you can request, as I mentioned, on the right-hand side there, a meeting for next steps. And we'll do our best to address any leftover questions via email and or via follow-up meeting. So thanks, Neil, for your presentation. Made it all the way through perfectly glitch-free. And we'll get these questions answered via email and via appointment scheduling.
Okay, well, thank you very much for having me this afternoon.
You got it. Thanks, Neil.